session on interview question series for VLSI Industry. So let us start with new question. Draw frequency response of common source amplifier. And second question is, what is the DC value at the output of common source amplifier? So frequency response of common source amplifier is a low pass filter. This is a FH, high cutoff frequency. Okay, this is the frequency axis and this is the gain axis, and here if you see the maximum gain is GM R out. Okay, GM R out. So this question was asked in one of the interview round of VLSI Industry. So you just need to draw a frequency response. You need not to do any mathematical analysis. But how this comes, how this low frequency curve comes when we do the AC analysis of common source amplifier, I will let you know. So for doing the AC analysis, we need to take all the parasitics. So here I have drawn a very simple common source amplifier circuit. Now I will draw a small signal equivalent model assuming all the parasitics. Okay. So now suppose this is a V in. Okay, so here this is a AC source because we are going to do the AC response. Now this AC source is having some internal resistance Rs. Okay, this is a capacitance, this is the gate terminal. So this capacitance is CGS. This is CGS. Capacitance between gate and drain is CGD. This is current source GMVGS. Okay. Now, if you take bulk, then this is CDD, and one more thing, you can take some R out also. R out, RL, whatever you want to take it. Here we are taking some V out. Okay, V out. So now we need to find out the V out by Vs or V out by Vn. So I am taking here two nodes, node 1 at input side and node 2 at output side, because this is the gate terminal and this is the drain terminal. So I am writing the equation at node 1. Node 1 equation will come. This is the gate terminal, so VGS minus of, VS, this terminal node is VS, so VS minus, I will write VS minus VGS, okay, VS minus VGS, okay, divided by RS. This RS you can say VS minus VGS divided by RS minus of VGS, this is VGS, J omega CGS, okay, minus of GM, okay, VGS J omega CGS for this capacitance, this VGS capacitance. So So VGS, J omega CGS, now VGS minus V out. This node voltage is V out, node 2 voltage is V out. So here VGS minus V out and capacitance across this is CGD. So J omega CGD is equals to 0. This is the equation 1. Now equation 2 at node 2 will come VGS minus V out. Okay, VGS minus V out divided by VGS minus V out. Okay, and node 1 minus node 2 voltage and capacitance across it is J omega C G D. Okay, now node 2 we are applying KCL at node 2 means this current GM VGS. Okay, now V out J omega C D B. Okay, CDB capacitance, this one, and one more thing, R out. So V out by R out. So when you solve these two equations and will take some approximation, you have to approximate it little bit, then only you will get a term V out by V in or Vs if you have taken is approximately equal to minus Gm R out divided by 1 plus J omega Rs CGS plus Rs CGD 1 plus Gm R out plus R out CDB. Okay, so this equation is a form of low pass filter. Low pass filter equation, if you write, you can write AV omega is equals to AV LF magnitude of low pass filter divided by 1 plus J omega divided by omega h, high cutoff frequency. So this equation is the form of low pass filter. That is why common source amplifier AC response is a low pass filter, whatever I have drawn here. Now next question is, what is the DC value at the output of the common source amplifier? So DC value at output means drain terminal. So if you want to operate this amplifier in saturation, means VDS should be greater than VGS minus of VT. Okay, or you can write VD drain voltage or output node voltage should be greater than VGS minus VT, and VT you can take approximately VT is approximately 300 to 400 millivolt. Okay, this is also in millivolt. This is a VT. So approximate output voltage, output DC node voltage when your amplifier is operating in saturation. Okay, so this is the, or if it is not operating in saturation, if it is operating in linear region or some other reason, then similarly you can find out the output node voltage value, approximate value or intuitive value. So here in this equation, from getting this one or two node equation to this final output, final gain, AC response of common source amplifier. If you get any problem in calculating these equation, you please write in comment section. I will give you the detailed derivation of this AV, AC response of common source amplifier. If you like the video, please like, hit button, and don't forget to subscribe the channel. Thank you for watching the video. Thank you.